today we are now going to solve question 4 of 2016. So we have some trigonometry here. So the MAT solutions I read is actually quite complicated, but no, we're going to solve this question using an overly simplified but overly effective method. So here we draw a circle of radius 1, and so we are now going to use the bisector to bisect it. This looks good. And we are going to draw a line from the center down. This is 1. We are going to write our distances and angles down because it's necessary convention. This is 1. This is alpha. So what is the center of circle C1? So if you do some trigonometry, this turns out to be 1 over tangent alpha, which is also equal to cot or cotangent alpha. So the center of circle C1 is, let's write it here, cotangent alpha 1. So we can simplify this and turn this into the circle formula to get x minus cotangent alpha squared plus y minus 1 squared equals to 1. For what value of alpha to circle C1 and C2 touch? So we are going to draw an imaginary circle here. Yeah, it's an invisible circle. I'm right. So this allegedly shows that this is 1, this is 3, and you want them to touch, you had to use some similar triangles. So this side, this unknown side turns out to be the cosecant of alpha because it used the sine cos is 1, and then you divide the whole thing by you must divide the whole thing by sine. You would get cosecant squared equals to 1 plus cotangent squared. Got that? So what this value of alpha is that. So what kind of alpha the circle C1 and C2 touch? So we are now going to say that 3 cosecant alpha equals to cosecant alpha plus 4. That is actually very simplified, but it's actually a very effective method because sometimes the solutions might turn out to be very complicated, but somehow you find a simpler solution which has to do with the geometry. Which brings me to something. While I solve for alpha, I am going to tell you that this visual thinking is actually very potent in these situations where you have geometry. Now you might be thinking, geometry, how am I going to use my visual thinking? You just have to use the intuition, and you might throw in some trig if you want it. So for this value, for this guy, a third circle larger than C2 is to be drawn, just touches both lines as well, and also touches C2. What is the radius on this circle C3? So I thought we were going to do some trigonometry. So I first did this question and then did some complicated trigonometry involving similar triangles and whatnot. But it turns out there's a simpler solution. We can actually enlarge this diagram by 3. So that means this will be 3. And then the radius of circle C3 is 9. For the same value of alpha, what's the area of the region bounded by the x-axis and the circle C1 and C2? So basically we have to calculate the area of this trapezium. So cotangent alpha, this thing here is actually 2 cotangent alpha, and cotangent pi over 6 is root 3, is twice the square root of 3. So the area of trapezoid, let's write it this way, equals to 1 plus 3 times 2 root 3 over 2 equals to 4 times the square root of 3. For the same value of alpha, what's the area of the region bounded by the x-axis and the circles C1 and C2? So we're now going to calculate the area of the sectors. So this is the area of the first one is pi over 2 minus alpha, and then the one or the big one is 3 squared pi over 2 plus alpha over 2, because it's supposed to be half r squared theta. So that's similar to the area of a triangle in it. Well, it is, so no time for that now. So alpha equals to pi over 6. So this is 5 pi over 12, and this is 7 pi over 12 equals to 21 pi over 4. So what's 5 pi over 12? 5 pi over 12 plus 21 pi over 4 equals to, this is a difficult one, 68 pi over 12 equals to 17 pi over 3, which means that we now have the answer to be 4 square root of 3 minus 17 pi over 3. There! It's done! And as you can see, a little bit of visual thinking can get us a very long way. So, see you in another MAT video. I hope this video has enlightened you about the secrets of visual thinking and how a very complicated question like this, and then you throw some thinking in, you can actually go a long way and probably solve the question. So the MAT not only needs math skills but visual thinking. So I'm sorry to have postponed this outro, but see you.